Bienvenidos, Husham indeed, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Introduction to Networks version 7 course, or ITN version 7. And in this packet tracer tutorial and solution set, we're going to be taking another very important look at subnetting. And so in packet tracer 11.7.5, we're going to be faced with probably our greatest challenge to date here in terms of the application and practical use and applying these subnet addresses and information. So you can see at the very top here, we have an addressing table. However, that addressing table is 100% empty in terms of IP addresses, subnet masks, and default gateways. So we're going to define an IP addressing scheme or design an IP addressing scheme. Then we're going to be assigning IP addresses to devices in the network. Now, here is the network address that we have been given, the 192.168.100.0/24. Now, this is going to be super convenient for us because it's a Class C address by default, meaning that the most familiar part of the subnet addressing we've been doing for quite some time here in the course at this point for a number of weeks. And we are going to take that /24 and we are going to create a series of smaller subnetworks, right? So that one network right here, this /24, where in the last octet of the address, the last 8 bits inside that address are the host bits, meaning I have 2 to the 8 possible IP addresses, meaning 256. And if I subtract 2 from that, it leaves me with a total number of usable host IPs of 254. And so what we're saying here, right, and here's the use case for subnetting, is that I don't need an entire /24 for this network and this network and this network and this network. I can take one /24 and subnet it into multiple subnetworks and simply right size that subnet so it's closer to being reflective of how many actual hosts I need to support. Now remember, in the note for this activity, it was pointed out that we are not using variable length subnet masking. We are using fixed length. And what that means is whatever subnet length we come up with, that same subnet length, a /25, a /26, a /27, whatever the case may be, that is what we are going to use for every single subnetwork. Now remember, over here, we have our layer 3 devices. These are routers, and routers break up broadcast domains. In fact, this router interface is going to be one broadcast domain, and that router interface is another broadcast domain. And remember, in this context here, a broadcast domain is a subnet, is a VLAN. And so what we have is we have 4 broadcast domains that we're dealing with over here. 4 subnets, 4, and the VLAN numbers may be the same. It's probably just VLAN 1 all the way through, but you can think of it as 4 mutually exclusive VLANs. Right? There's no communication between switch 1, 2, 3, and 4 with VLAN information. So when I say that what we're dealing with here is 4 individual subnets, 4 individual broadcast domains, which will each have their own broadcast address, they are 4 individual VLANs, right? So you can continue to use that, these are individual VLANs. All right, so we take a look back up here. Each LAN requires at least 25 addresses. We see that over on the side. And let's see, for the end devices, the switch and the router. And this is going to be one of those activities where we're probably going to be asked to assign the first usable address to the router interface for the subnet in question. The second usable IP, maybe to the switch. The last usable IP, maybe to the PC. And we'll see as we work our way down here. So here is the addressing scheme. Let me clear the screen here and let's scroll up or scroll down a little bit. So let's design our IP addressing scheme. So based on the topology, how many subnets are needed? And I'll kind of type these in as we work through here. Well, remember, we might want to take into consideration, hey, is there a subnet here? And we can take a look and see. My guess is that it's going to be 4, that it's going to be these 4 subnets over here. Maybe we have a 5th one right here, which would be the transit segment, this point-to-point serial connection between router 1 and router 2. So for right now, we'll go ahead and say we need 4. How many bits must be borrowed to support the number of subnets in the topology table? Now, this is a question that might lead you down the wrong road. So if we look at this and we say, I need 4 subnets, we remember from our equation that 2 raised to the number of borrowed bits, that is the number of subnetworks created. So we might look at that and say, oh, well, I only need to borrow 2 bits. In other words, I'm going to create 4/26s. That's what I'm going to do. But let's make sure that that's going to be what they're looking for here. So again, how many bits must be borrowed? Well, if we only need 4 subnets, we would borrow 2 bits. If I needed 8 subnets, I would borrow 3 bits. If I needed 16 subnets, I would borrow 4 bits out of that last octet in the IP address. And we're borrowing the host bits, flipping them to make them network bits. So how many subnets does this create? Well, it would create 4 if we borrowed 2 bits. How many usable hosts? And again, usable being the key word, not total, usable. So we're going to get the total number as part of the equation we work out. However, let's go ahead and figure that out. If I borrow 2 host bits, that leaves me with 6 host bits in all. And we would say 2 to the 6. Well, 2 to the 5 is 32. 2 to the 6 would be 64. And then we take away the broadcast and subnet ID addresses. That's the 2, leaving me with 62 usable IPs. Now, if your answer is less than the 25 hosts required, then you borrowed too many bits. So what if I would have borrowed 3 bits? That would have left 5 host bits behind. That would have left me with 32 total IPs. Take away the 2 for the broadcast address and the subnet ID, it would have left me with 30 usable. So now we're kind of in a scenario here where, okay, they're asking for here, how many bits would I have to borrow to meet the number of subnets, which leaves me with 62 usable IPs in each subnet. But we only have 25 hosts. And again, this raises the question, would this not be more manageable? And you can see down here, they've listed out 5 total subnets down here that we might have to deal with. Or at least where they've got the bits and they're asking to calculate the binary bits of the first 5 subnets. So if they're asking to calculate the value for the first 5 subnets and borrowing 2 bits from the host bits in the last octet only results in 4 subnets, then the answer is not going to be 2 to the 2 because that would cap us at 4. We would have to go to 2 to the 3. We would have to borrow 1 additional bit, meaning this is the value that we would have, which is more in line with what we're looking at. And again, the 5th subnet here, I'm assuming they're waiting or they're looking for us to take this into account here. So it may look like we're going to do 5. And again, we'll check as we work through. So, but this is sort of the thought process that we can use to determine, hey, how many subnet bits am I going to borrow? All right. So let's calculate the value for the first 5 subnets. And you can see here. So subnet 0, where we have all 0 bits. So bit 7, 6, 5, 4, 3, 2, 1, and 0. So all 8 bits are 0, right? And so if we look here, they're having us go up by, and this is kind of, it's really weird when you look at it like this, and then they throw this 1 out here. You're like, okay, well, it's bit 5. Well, 128, 64, 32. Well, we kind of already know the block size, don't we? So if the block size is 32, it's 0, 32, 64, 96, and 128. And yeah, it is going to be 5 subnets. I'm sorry. So this 5th one is going to count. Definitely going to count. All right. So there are the 5 subnets that we're working with. 100.0.32.64.96.128. Those are the subnet IDs. Now, they kind of want you to fill this out here. So we'll say 0. Oops, sorry. Pull that back. 0, 1. And then I'll just say quickly here 0, 0, 0, 0. These are all going to be zeros down here. And I'm just going to draw a line in the zeros from here on out. All right. Then 96 would be 64 and 32. So 0, 1, and then all zeros. And then 128 is 1 and then all zeros. So here are the first 5. Remember, if we borrow 3 host bits, we're creating 8 total subnets. They're just interested in the first 5 because that's what we're going to be using. And my guess is that 5th one, this 128, is going to be right here, right? So calculate the binary and decimal value of the new subnet mask. Well, if we've borrowed 3 host bits, we changed it from a /24 to a /27. So all of our subnets will be /27s. And what that means is the 4th octet would have been 1, 2, 3. The first 3 high order bits in binary for this last octet, we borrowed those. We stole them from the host bits. Because again, we need more subnets and fewer IPs. So we borrowed some of those host bits, these 3 right here, and now they want us to calculate this value. Well, it's 128 right here, and then 64 in that binary bit position, and then 32. And we end up with 128 and 64 is 192, plus 32 is 224. So now this is our subnet mask in dotted decimal notation. So down below here, it says fill in the subnet table listing the decimal value of all available subnets. So it wants the decimal values for all available subnets. Well, let's clear our screen here. And let's go ahead and scroll down because this is where we're going to kind of hit the top, or the bottom, I should say, of this activity for the most part. So they list out all of these subnets here. Now, I think it's interesting that they come down here all the way to 10 when we're only going to have a total of 8. So these last 3, I don't believe we're going to be putting any information in there. The decimal value of all available subnets, the first and last usable host IP in the block, repeat until all addresses are listed. Look at the little note right here. So they kind of try to throw you here. I mean, they know that we're only using the first 8. So why is it that they put 8, 9, and 10 here? Right? So 0 through 7, they know that's what we're using. But they drop these 3 here in just to make sure that you're thinking, hey, am I sure that there's only 8 subnets here? So I'm not going to put the 192.168.100. We'll just go ahead and say the subnet address is .0. And again, we'll work our way up here, 32. And we'll fill everything in. And this is going to be 64. And this is for all 8 of those subnets, .96. .128, .160, .192, .224. Now, this is where you might say, oh, yeah, right, and then add 32, 256. Can we get 256 as a value? We cannot, so no. We're done right there. So first usable IP is going to be the first addressed after the subnet ID. So .1, .33. And everything kind of starts to fall into place here. .65, .97. That's a terrible 9. .97, .129, .161, .193, and .225. Whoops, 225. I'm just going to put big X down here for these last three because we know we're not using any of these guys down here. All right, last usable host IP. Now this one kind of gets tricky, right? Because you might say, oh, right, the last usable host IP is one less than the network ID of the next subnet. Now remember, that's the broadcast address. So my recommendation here would be to do your broadcast address first. So .31, .63. And again, you can see the block size, the values are just going up in 32s. .95, .127, .159, .191. And this is kind of making it so there's less math for us to worry about. 223, sorry. And then finally, 255. And so from here, now it's easy. We just subtract 1 from the broadcast address, and that's going to be my last usable host IP. So 62. And you may notice a pattern here. The last usables in our setup here are all even numbers. The first usable are all odd. The subnet IDs are all even. The broadcast addresses are all odd. So remember that when you're working these values out. And that's a 2, 126, 158, 158, and then 190, 222, 222, and then 254. All right, so those are the values we're going to be working with here in this activity. So now is when the rubber meets the road, because now it's time to start assigning things. So let's dive in here. Assign subnet 0 to the LAN connected to the gig 00 interface of router 1. And I like how they label it so we don't have to mouse over it. So here it is right here. Well, let's click on router 1. Let's give ourselves some room with which to work. Sort of a larger canvas here. And let's see what's configured right now. So show IP interface brief. Is anything configured? Well, lo and behold, there is that serial interface, the 5th subnet range, using the .129. Let's do a show run and let's see if they used a /27 like they've had. And look at that. There is our subnet mask in dotted decimal notation. And sure enough, it is a /27, which in dotted decimal notation is 255, 255, 255, 224. All right, so let's go ahead and show IP interface brief. I forgot already what we've got here. Okay, so let's get into global config. Let's get an interface gigabit Ethernet 00. And let's see. Okay, so we see the different subnets here, right? So these 5, and there it is right there. Yeah, so the WAN links we're going to be doing some work with. So subnet 0, but then it's down here where it's actually kind of saying, like, what are you assigning to what? So assign the first usable IP addresses in each subnet to router 1 for the 2 LAN links and the WAN link. Well, the WAN link already has that first assignable IP address. And so what we want to do here, we're in int gig 00, and we're going to use the first IP in subnet, with subnet 0, basically. They're doing the 0 counting thing here. So IP address 192.168.100. First usable is going to be 1. And the subnet mask, right? Remember, we're doing fixed length subnet masks here. Fixed length subnet masks. We are not like switching it up. So that 255, 255, 255, 224, you're going to see that a lot as we work through this activity. And let's throw a no shut on that interface. Let's get into gigabit Ethernet 0.1, and you can see we got 23% for that. So on gig 0.1, we're going to use the first assignable IP address in the second subnet, which is going to be .33. So let's go ahead and say no shut, and we'll say IP address 192.168.100.33. And there is our familiar 224 subnet mask length. And you can see we jumped up to 46% there. So that takes care of the router interfaces. Again, the LAN link do show IP interface brief. The WAN link is already configured, and we looked at the subnet mask length. Everything looks good. So let's go ahead and do a write mem here. All right, now over to router 2, and so interesting. The configuration is locked for router 2. And I did not see it say anything, so how could we get around this, right? Let's think outside the box. I need to connect to router 2. There's no IPs assigned, but how else could I connect? Yeah, maybe I can come down here and grab, of course, the connect links is locked. I was going to come down and grab the console rollover cable and jam a console connection into router 2. Is it the config is locked for all of these? I wonder if they're going to have us. Boy, that is interesting. So, okay, let's see. And maybe this is what they're trying to get at. I'm going to read down a little bit further here. EIGRP is running configure about. Yeah, okay, so this is the only other way I would think about getting around. Let's try Telnet first. So we're going to try to Telnet to router 2 over the serial link. And let's see if this works. 192.168.100. So if we're using 129, it means that it's probably 130 would be my guess. And we could play the ping game here to try to ping that serial interface to see, because it's clearly not 130. Let's see, and they don't give us any of that information up there. So I'll pull this back down here so it fits into our table nicely. So assign the subnet to the WAN. Well, it is locked. The configuration is locked. And so now it's got me wondering. Let's give SSH a try. Let's see if we can SSH to 192.1. Actually, let's see. Let's confirm. Ping 192.168.100.130. Is that the actual address? It doesn't look like it. All right, let's try Control-Shift-6. Let's try 131. Because it would... Oh, yeah, that's right. So it's either going to be 130. Boy, there's a lot of addresses in this range. So there's got to be show IP ARP. Let's see if it... Okay, so I'm only seeing gig 01 and 02. And let me check the instructions. Did I skip over something up here where it was telling you how to configure things? It does not. So it looks like we're not going to be able to configure router 2, which doesn't make any sense because it's going to leave us short on this activity. You can only verify connectivity from router 1, switch 3, and PC 4. Okay, well let's... Okay, so the switch is locked. All right, well the switch is unlocked. Well, there's no IP address on that interface, so... Let's show IP ARP. Let's see what it sees. What about, yeah, so we've tried to, we've tried to SSH in, we've tried to Telnet in. Config is locked on all the PCs, and the config is locked. You should be able to ping every IP address listed in the addressing table. Huh. Configure PC4 with the host. Configure the PC4 host with host and default gateway information. All right, let's try this. Let's see if this stuff is already configured. So maybe router 2, maybe these interfaces are already configured. We're not supposed to get on there. Again, as I'm reading down here, just trying to find another way through the activity. So, because it's saying assign subnet 2 to the LAN connected to router 2, and then subnet 3 to the gig 01 interface that's on router 2, and then assign subnet 4 to the WAN link between R1 and R2. So let's assume that R2 is configured. Okay, let's go with that. So let's come into global config here on the switch. I'm skipping down to step number 2, part 2 to see if this is the second usable IP to the switches. Okay, so we'll go into interface VLAN 1. I'm going to say no shut right out of the gate so we don't forget. And then the second usable IP gets assigned to the switches. So IP address, and this is the gig 00 interface. This is going to be subnet number 2, the third subnet. And so the second usable in subnet number 2 would be 66. So let's say 192.168.100.66, and we'll put that very familiar. Subnet map, and that actually gave us quite a few points. Let me save the config here and let's test it. Let's see. Can I ping the router interface? 192.168.100. What would be 65, which is the first usable in that, and lo and behold, it is configured. Take a look at that. All right, so, okay, so reading ahead in the activity is definitely a plus here. So switch 4 we can't configure, switch 3 we just did, switch 2 we can't configure, and switch 1 we can't configure. All right, so it looks like, as you can see here, configure the R1 LAN interfaces. We did that. We configured switch 3. Let's go ahead and configure PC4. And it looks like, again, they're just challenging us by kind of jumping to certain devices, but not all of the devices. So 192.168.100. Now here's where we need to figure out. PC4 is on the 4th subnet, which would be subnet number 3, because they started with the 0 base counting. And so for the PCs, assign the last usable IP to the PCs in each subnet. So subnet number 3, which is the one for this router interface that PC4 hangs off of here through the switch, is going to be 126. 126. The subnet mask, we want to make sure we change that to 224. Now, the default gateway is going to be the first usable IP address in the 4th subnet, subnet number 3. And that's going to be 192.168.100.120, wait, .97. Pull that back. All right, let's see what we've got here. So that took us to 90%, and let me make sure I got my values correct here. So the last usable IP in that range, that subnet number 3, which is the gig 01 interface on router 2, this subnet right here, the last usable is 126. The subnet mask is correct. 192.168.197 is the first usable, which would be the IP on that link. So that is correct. And let's go ahead and let's test out. And definitely a challenging activity and an odd activity, to say the least. And let's see, can I ping that first usable IP, which is router 2? And we can. Let me see if I can ping over to PC1 on gig 00. So can I ping all the way over to 192.168.100.30? And that would be the PC1 address up there at the very top. But I'm not sure if the routing, again, it said EIGRP, so take a look at that. Everything looks good. And we could have looked at the router to see, are we, do we have an entry for all of the routing information we need? But that's outside our scope at this level. Okay. So we're missing something here. And again, this is an odd enough activity to where, switch 3 default gateway, of course. Of course, it's the switch 3 default gateway. All right, so let's bring this back over here. And it was on switch 3 where I left out. I didn't see that in the instructions as I was trying to figure out what it was we were supposed to be doing. 192.168. Okay, so switch 3 is on the gig 00 interface on router 2. That should be subnet number 2. And the default gateway will be .100.65. And there you have it. We are now at 100%. So now can this switch 192, can I ping 192.168.100.30? So can this switch ping PC1 and everything works as expected? And so again, definitely a challenging activity. Make sure to confirm all of the pings that you can ping everything. And that is going to do it for what is probably by far the most challenging activity that we've worked with here in terms of subnetting so far. All right, guys, thanks for watching. Let me know if you have any questions, and I'll see you in the next video.